Right, you can see here a timing diagram of both read and write in a single sketch. Right, you can see here both read and write timing diagram. Right, you can see here. So this particular one is that whether it's a memory read or write timing diagram. Right, so or you can say that whether it's a memory of 8086 minimum mode. Right, you can see here whether it's a memory read operation or memory write operation. Right, it will take 4 t states. Right, 4 t states. Right, so see, you can see memory read here, memory write. Right, previously in the previous discussion we already discussed memory write. Now you can see memory read also here. Right, for every operation processor is going to take 4 t states. In between t3 and t4 it's going to take some time, that is the waiting time. For example, peripheral devices, slow devices there, it will take some waiting time here. That is the reason here extra thing, waiting t state is going to be added here. Right, so normally this is going to be varied, but remaining all t states, this one or this one, everything is constant. Right, this time period is going to be depending upon the clock frequency. Previously already we discussed this particular one is the 0.1 microseconds if you connect here 10 MHz clock. Right, so like that you can see here. Right, so 4 t states to perform the memory read operation, 4 t states for memory write side operation. In the similar way, the next operation may IO read or IO write or something else. Right, so for every operation, whether it's memory read or write operation, so how these particular signals are going to be varied, we need to understand here in the timing operation. Right, so previously also we discussed this particular one. See how these particular signals are going to be varied from the microprocessor. So now it is communicating with memory. We already know in minimum mode configuration what are the things are there in between the external memory and processor. Right, so but from the processor, how these particular signals are going to be outing from through this particular pins, right, with respect to clock. If you draw the graphical representation, that is going to become the timing diagram. So right, you see this anyway previously also discussed. Address bus is coming to the picture, control signals are coming to the picture, and data bus is going to come to the picture. Right, so address bus, here you can see this is the multiplexed address and data bus. Right, these are the control signals. Right, so see here ALE is going to be high during the first t state. Once ALE is high, then what will happen? Address and data, multiplexed address and data bus will act like a address bus. That means what? These are all, this is going to be address A0 to A15, this is A16 to A19, like that 20 address lines. Whatever the data, that means bit combination is there on that particular 20 pins coming out from the processor, is acting like a address. Once it is address is there, that is used to select the chip as well as particular location in the memory. Once it is selected location, then what will happen? This read control signal, see, up to that time it is high only. Once it is selected, then it's going to be low. Once it is low, then what will happen? It is going to be read data from the selected location to the data bus. Through data bus, it is going to be read into the processor. That is going to be read into selected. Then control signal is memory read control signal. Right, through data bus, now data is reading to the processor. Once it is selected, that is the reason it is low here. See, by that time data is enabled on the data bus as well as it is transmitting or receiving. It's the receiving, that is the reason it is low only. Right, so this is ready signal, is just wait signal. Right, so after T4 state, see, after first mission cycle, memory read cycle, memory read cycle. See here, by this 4 t states end, this memory read cycle is completed. Now memory write cycle. Once again, in first t states ALE is high. Once ALE is high, same multiplexed address and data bus and multiplexed address and status lines is acting like a address bus. Once again, to select this particular chip as well as to select some other memory location, right? This ALE is high means whatever the data on this particular multiplexed address and data bus will act like address, and it's going to be select the chip as well as to locate the register, right? Now control signal, see, this is read control signal is high. It is high. Now it's not a read operation. Processor don't want to make read operation, it want to make write operation. That is the reason read signal is high only during the total write cycle, right? So but this write signal, you can see here, write signal after T1 state, right? So write signal is up to that time it's high only. Why? Because the previous cycle it's the read operation. That is the reason read is low, write is high. But now in this write cycle, write operation, that is the reason write is low after T1 state, after AL is made 0, right? It is low, and this one read is going to be high, right? So data is available on the data bus. Once read is write operation is low. Write means what will happen? Processor has some data that is need to be write into this particular memory location. That is the reason that is first going to place in the data on the data bus. That data is going to be out to the memory location. Write operation is going to take place. Once write operation is going to take place, data is available means data is enabled on the data bus. That is the main reason. This is low. Write is low means what will happen? Write operation is going to take place from the data present on the data bus to the selected register location. Once again, if write is completed, once again it is high. Once it is write is done, it is also high. So by this time, this is the second cycle. Write cycle is also going to be completed. The next cycle may be anything. Based on that, once again these particular control signals are going to be varied. Once again, AL is high. These are act like address bus, right? Then like that, based on these control signals, data writing or reading operation will take place, right? So like that, you can see both write and read cycle in the single stretch in this particular timing diagram, right? This is the timing diagram for memory read and write, right? So from this you need to understand this, that right, if question comes like this, only once only read cycle if they want, you need to write this one only. If they ask only write cycle, the previous discussion, or you can write by understanding this one also, only this one. Write and read, you need to write overall together, right? So this is the explanation of timing diagram of read and write of 8086 processor in minimum mode configuration, right? So thank you. Just understand this particular one and write down according to that, right?